Okay, so let's get started. Before we learn about the soil characteristics that we all will be doing small activities here in the classroom, we have to collect the soil sample. So we will go outside and collect the soil samples and we will come back and use that sample during our activities. Okay, all ready?
Yes.
Okay, let's go. We need to learn about the characteristics of the soil physical properties, soil chemical properties, soil biological. For that, we need to collect the representative soil sample. So we do have a cheat sheet on collecting the soil sample in the workbook that we got it. So that's for the plants in the gardens, but you can always use that to collect the soil sample to do any classroom activity. Okay? So we have to collect the representative soil sample. It's always important to see the change in the soil visually when you collect the soil sample. So if you are going to collect the soil sample in your backyard, scrap the top, the plant mass, or if you see the mulch, don't take the mulch into the consideration. Scrap that off and use this. Can I borrow one of these? Yes. So I'm not going to pour here. So hold it tight like this. Okay, then press it on from the top. So this will go. So what we are going to collect is about 6 inches. That's good enough for our soil in classroom activities. But if you are doing in the classroom, so make sure you collect enough for your students to use in the classroom. Okay, and if you are doing, we always ask you to make a plot map. And there are some flags in your buckets too. You can use those flags too, even though you can use it for some other activities. But you can always flag the area from where you collect the soil sample. That way you know what you are going to diagnose and what the characteristics are. Okay, so it's always important to scrap from the top, remove the plant matter. If there is mulch, remove that. Use this auger, soil probe, put the pressure from the top and get it into the deep. We go with the 6 to 8 inches for most of it. We are not going to dig a deep pit here. So 6 to 8 inches is good enough. Ask your students to do it at several spots. That way they can collect enough sample for their in-classroom activities. Once you collect the sample, you can use your bucket or small plastic totes or something. Put the samples together in the bucket, okay? And then mix it. Mix the soil sample. We are not going to do it today because we are collecting your own sample to do that in the classroom, in our classroom. But if you're doing for the students, mix the soil sample and then take that sub-sample and ask the students to do the activities in the class. So that's how it will go in the classroom. But here we will collect 6 inches today or less, depending upon how much bush you can do. And then we are going to put that in the bag. So in the bag, you don't have to label it since you are using your own. But if you are doing the different colors, different slopes, different parts of the property, then you can always label the bag. Okay, label the bag, put the date, and how much, and from where you collected. Sometimes we use the notebooks to keep a track from where you collected the soil sample, which date you collected, how deeper. You can take a layout of the plot, how you collected and where you collected. So that's a handy note that would help when you want to come back and do the activity next year. You always get to know what was that in the last year and you want to make a change or you want to keep the same. So this will help you. Okay? So let's do a little bit exercise this morning. Do a little push and get the soil sample. I would say just one board should be good enough for our classroom activity. And then we can put that in the Ziploc bag and we will go back into the classroom. You can wash your hands and then we will get started. Okay, so let's define the soils. The soil is defined as the unconsolidated mineral or the organic material that's on the immediate surface of the earth. It is also known as the skin of the earth. and it's the medium for the growth of the land plants. So this is the definition of the soils as per the Soil Science Society of America. So we will learn more about this, and what it's saying is soils are dynamic. They're constantly changing over time.
Yeah,
So what is soil made up of? So soil is composed of minerals, which is sand, silt and clay that are derived from the rocks. Then we have the organic material, which is living or the dead, and also air and water. Since we all need air and water, right, to breathe and to be there. So soil is also composed of air and water, and that helps plants to be living on top of that. So it forms at the surface of the land, also known as the skin of the earth. The composition of this, the mineral and the air, water, or the organic matter changes. So we will learn more about it in the next few slides. The other thing of defining the soils or mentioning about this composition is it comprises of three phases, which is solid, liquid, and the gases. So solid is the minerals and the organic matter, and then we have the liquids like the soil solutions, water where the nutrients are dissolved, and then we have the gases, like we need gases breathing, right? So they do have the gases. So the composition varies. The solids are about 50%, with the minerals about 45%. Then we have the organic matter from 1 to 5%. And the liquids and gases about 25% each, but they constantly change. When we have too much waterlogged soils, then the air definitely decreases the amount. But if we have well drained, then it's normally 25-25. So depending upon the conditions of the soil, their composition changes. So let's learn about the soil-like material, which is the minerals and the organic matter. So the minerals is again the inorganic, which is sand, silt and clay, and derived from the rocks. Then we have the organic matter, which can be either living or the dead. So the living material can be bacteria, actinomycetes, worms, critters, and then the dead material can be the leaf litters, dead roots, decomposing critters, and all those decomposing matter, or the living dead material. So where is that outside the organic? Then we have the air and the water. So what's the pore space? The pore space in the soil represents a part of the soil that's not occupied by the solid, which means that's occupied by the air and the water. So in this soil we have a space which is not occupied by the solid, then we have the air and the water in that's the pore space. And the air and the water composition, as I mentioned, it fluctuates depending upon the conditions of the soil. If we have waterlogged, more water, less air, so it depends upon how the soil conditions are. And also this is the pore space where the plants or the animals, the habitats, it provides the habitats to those organisms too. So let's talk about, is soil the dirt? No, since you all mentioned in the morning, it's a living, right? It provides the nitrogen fixing bacteria. It provides if there is no soil, there is not going to be any life. So soil is not a dirt. And dirt is just a 4-letter word that we won't be using in this workshop. We will be just using the soil. Okay. And in the classroom, it's always good to use the soil rather than a dirt too. So what is the dirt? So dirt is any stuff under your fingernails, or when we get the dirt on our clothes. It's all the dead material. It's not a living material. It doesn't have any characteristics to support the life. So if we have the plants, right? If we have what we call the weeds are the plants which are out of the place. So that's our weeds, right? Those are not the plants. So similar is the dirt. So the soil which is out of the place is termed as a dirt. So it doesn't have the characteristics to support any living life. So it's all dead material. Whereas the soil is essential for life. So which means soil is not a dirt. So why is soil important? So soil is important, as we all know, it's a media for the growth of the plants, right? It provides the nutrients, it provides the water, everything that the plant needs. It holds the root firmly, provides the support for the plants to grow. It also modifies the atmosphere by emitting or absorbing the gases such as carbon dioxide, water, vapors, methane, and dust. The other important part of the soil is it provides the habitat for the animals. It provides animals the habitat, that's how they live under the ground, and also provide the media for the construction, right? All the buildings are laid on top of the soil. So it's a media for the construction. The additional part is it acts as a living filter to clean the water, right? And then also has to capture the carbon, reduce the carbon from the atmosphere, which is known as the carbon sequestration, that we store the carbon in the soil. So its soil is very, very important, and these are just a few points listed that what important role the soil plays. So this makes a great mud pies, and also it's just a plain fun. And I hope you enjoyed the exercise this morning collecting the sample. Okay, so that was the basics of the soil. So it includes a little bit more on the formation. So that was the definition that we just talked in the composition. So let's learn about the formation factors, the soil formation factors. So there are many different types of the soils in the world, about more than 10,000. And they are different because where and how they are formed. So that defines their composition. And actually it's different from one part of the world to the another. And even also from, if you go from one part, here outside, it was too muddy on the one side and it was too dry near the roses. So it's so different even within the small area. So they are different because how and where they are formed. And these are the five factors that leads to the soil formation. So you can also, in the chart, you can see as ClORPT. So C for climate, L for landscape or relief. Then we have organisms, the parent material, and the time. And it's not that each factor is important. The soil is formed through the interaction of these factors. So they interact and leads to the soil formation. And again, no one factor is more important to the formation, it's all their interaction. So we will learn about these factors one by one in the next few slides. So let's talk about the climate. So climate, it can have a profound effect on the differences in the soil, regional differences in the soil. And even if you see here outside, as I just mentioned, but if you say on the bigger scale, within an acre, within a little larger field, it's not going to affect, since the climate is not going to be changing on about an acre or 2 acres or in your backyard gardens. It does have a profound effect on the soil composition. So how that affects is mostly the temperature and the precipitation. So if they directly influence the weathering, the temperature and precipitation influence the weathering of the minerals, of the material in the soil, and that how it leads to the different composition of the soil. The other important factor is these factors affect the decomposition other than the weathering too, so that leads to the different composition. Are you okay with the slides? Okay. That influence the composition of the soil. For example, the soils that they develop faster in the warmer region than in the colder region, right? So that leads to the fastening formation process as compared to the.
I'm sorry, I didn't hear that. Can you say it one more time?
The soils, they develop faster in the warm regions than in the colder regions. In the cooler regions, they develop slowly, but in the warm regions, they develop faster. Yeah. So that's how the temperature and precipitation, they influence the soil formation process. The another important factor to discuss in the formation is the organisms. So we have the plants, animals, micro and the mesos, which are difference in the size. So if you have 2 millimeters between 0.2 to 2 is the mesos, and if you cannot visualize with the naked eyes, then we say as a microorganisms. So the organisms do influence the soil formation process. For example, the rods, these animals, they do lead to the breakdown of the rods with their roots. Sometimes the deeper the roots, they help with the formation process too. So the larger soil particles are broken down into the smaller particles. And the microorganisms, they also lead to the decomposition of the organic matter. So that also helps with the formation process. So these are some of the examples at how the organisms leads to the soil formation process. The another factor is the relief, also known as the landscape. So it influences the soil development. The primary reason is due to the drainage and the water movement. For example, the slope, the steepness, the soils on the steep slope, they don't tend to stay there with the drainage and the water movement. They come down, so we have the deeper soils in the lower part as compared to the top part of the slope. So that influences the soil formation process. The shape is the another factor, such as to which side we are getting more of the sun heat. So that leads to the different formation process. And elevation, as I mentioned, how steeper how much the elevation is. Even the elevation brings so much difference in the temperature. So the cooler and the little lower temperatures, that affects the soil formation process. The direction of the slope is another factor that influences at how much the sunlight the soil is getting and how it is drying, how much drying the soil is over there. So that helps with the soil formation process. So the other one is the parent material. As we all inherit some of the characteristics from our parents, the soil do too. So soil do inherit the characteristics from the parent material from where they are formed. For example, if the soils that are formed from the limestone, so they are rich in calcium. So that means they get some of the characteristics from their parents. And if the soils are formed at the bottom of the lakes, they are rich in clay. So that's how they get some of the characteristics from their parent material. The last important factor is the time. It is the length of the time that the surface has been exposed to the weathering and the biotic forces. So as I mentioned, it's not the one factor that's important, it's the interaction among all the factors that leads to the soil formation process. So the older soils, as you see, they are different from the younger soils because they have the longer time period to develop those horizons. But in the younger soils, it's difficult to see the horizons, which we will be learning in the next few slides. So all of these factors, they work together over time, and that leads to the soil formation process. Okay.
Question. When you're saying horizons, those are the layers?
Yes, those are the layers.
And do those layers form like uniformly, like you can see the layers, or?
You can see the layers depending upon the soil formation. Some they are younger, some are older, and not all the layers are present in all the soil beds. So it depends upon the formation. And also, as the soil ages, it start looking different from the parent material as soil ages, because the soil is dynamic. There is always a change from deposition, from the loss in the contents. The composition changes, which means it's always the ongoing process. They are dynamic. Okay, so let's talk about the soil profile here. As you mentioned, it's the layers. So when you take a deep pit, you will see the different layers. So the different layers, each layer is known as the horizon. And it's so different, as I mentioned, the soil formation process dictates this and how long it has taken. So sometimes these horizons are visible, sometimes they are not. And you won't see all the horizons in all the soil beds, so depending upon the formation and the longer the process. So this is entire, when you put all the horizons together, it's known as the profile. But when you take individually, these are called the horizons, okay? Together, profile, each one's horizons. So here are some of the horizons, and you will learn more about this in your cheat sheets here. The top one is the O horizon, which is the organic matter, such as decaying leaves on the roots at the top. That's the rich organic matter, O horizon. That's how it is, organic matter. Then below the O horizon, we have the A horizon, which is and which is mostly the minerals from the parent material, and with some organic matter incorporated, and it is good material for the plants and the animals, organisms to live there. Then below the A we have E horizon, which is eluviated horizon. It is a leaching of the clay minerals and organic matter, leaving a concentration of sand and silt particles. So this is E eluviated, which is light colored than the A horizons. And then we have below that it's a B horizon, which is rich in the minerals that move from the top A or the E horizons into the B horizon. Then we have the C, which is parent material, and below that is the bedrock, which is the mass of the rock that weathers, and that leads to the formation of other horizons. As I mentioned, sometimes we have missing E, so it's not always that all the horizons are present in the soil. Most of the soils, they have mainly the A, B, and C horizons, and we are missing with the other ones. So depending upon the soil formation, we can see these horizons or we cannot, so it depends where you are and how. But after you do.
The C was? I'm sorry.
The C,
Yeah.
it's a deposit at the earth's surface from which the soil is developed. It's deposit on the earth's surface after the bedrock from where the soil is developed. Okay, so that was the basics, formation, definition, and the profile. So now learn about the physics, soil physics a bit, and then we'll do the texture here in the classroom. So there are many soil properties that would help us to diagnose, learn about the soil. We can either do the physical, we can do chemical, we can do biological, and we have other team members here that they will be teaching us about the others, but we'll cover a little bit about the soil physics here. So what is soil physics? It's the study of the heat, water, and gas flow into, through, and out of the soil. And here are some physical properties listed, but we will be learning more about the texture. So one is the color, that's we'll learn in the next slide, and that influence it mostly tells about the soil mineralogy, what minerals in the soil is. Then we have the texture, which is the percentage of sand, silt, and clay in the soil. That determines the texture, and how it reflects how the minerals and organic matters, they combine to form the matrix and the pore spaces, right? And then they do tell us about the water holding capacity of the soil, right? If we have the sandy soils, they cannot hold the water, right? Because everything will be leaching down, but if we have the clay soils, they can hold the water more tightly, so that's determined by the texture. Then we have the permeability, which is the movement of the water to the soil. So that it, go ahead.
You said heat, water, and
Gas. Gaseous flow. So again, the permeability is the soil's ability to allow the water to pass through it. So the texture, they do influence these permeability, water holding capacity, nutrient holding capacity. So the texture is very important parameter to determine how well the soil can hold the water and the nutrients from the plant growth. So the soil color is mainly influenced by the soil mineralogy. If we have the orangish, reddish color, then it means deep orangish, brownish color, or the yellowish. Those are rich in the iron, as you see in the oxysols. But if they have the dark brown color, then they are rich in the organic matter. As you see on the right, it's the histosols. So mostly the minerals that tell us about the soil color, and also the organic matter can tell you about the soil color if they are brownish in color.
So for the oxysols, they're rich in water.
Iron.
Iron.
So sometimes the color, they do tell us about the behavior of the soils. If we see the patches, the soggy, if we see the brightly colored or the bluish patches, then it means they are not the drained soils, they are poorly drained soils. So we see bluish, grayish patches in the soil too. If we see the pit, then those are not the good soils, well drained soils. So those means those are wet and soggy soils. So do tell us about the behavior as well. Okay, so that comes the soil texture, which is the sand, silt, and clay that determines the soil texture. So every soil can be separated into the 3 physical sizes based upon the diameter. So the biggest one is the sand from about 0.05 through 2 millimeters, the biggest one, and then we have the silt, which is from 0.05 through 0.002 to 0.05. Then we have the clay, which is the smallest one. And we do have a chart out here showing the different sizes, with the green ones as the sand. Then we have the bluish ones as the silt. Then we have the small ones as the clay. So just to show you the different sizes of the sand, silt, and clay to use in the classroom. As I mentioned, sands are the largest and the clay particles are the smallest, and mostly the soils are a combination of all of these 3 sand, silt, and clay particles, and that tells us about the soil texture.
So, excuse me, so in this, in that demonstration, you said the big green balls, that's the sand.
The medium we got silt, then the smallest is the clay.
And there's one of those in each of your buckets.
They are in your buckets
And
too.
it's got that picture on the plan of it.
Does the soil separate like it does here?
They do.
Without the static.
What's that?
Not without the static.
When we do the texture, sometimes with the different methods, then you can see the different layers. So this is a soil texture triangle. There are 12 soil texture classes represented on this triangle here, and then each texture corresponds. We have 12 classes, sand to clay, then we have the different ones in the middle. Then this is what tells us about the sand, silt, and the clay. When we determine the percent of each category and see where the line coincides, wherever it falls, that's the texture of the soil. So we will learn about this in our classroom activity here. Soil texture by field method today in the classroom, so we'll get your hands dirty again. I apologize though. So we will be using the Natural Resource Conservation Service (NRCS) developed the field method to determine the soil texture. And this is the chart. I believe that's in your worksheet too. And to determine the soil, you just have to follow the steps to determine the soil texture using this method. And there is always a link to, when you click on this link, not right now in here, but if you just do the Google soil texture by NRCS, there is a flow chart that you can use to determine the soil texture to do the in-classroom activity. To do the soil texture here in the classroom, so we will use the soil sample that you collected. We won't be using the entire, but we'll take a small sub-sample of it, and we'll use this bottle. I put one on every table, so we will take turns, put few drops put the soil sample in your palm, little bit, then put drop-wise the water. We'll follow the steps that we'll be sharing in the next slides and try to make the balls, and all that will determine the soil texture here in the classroom. Okay, so the method, if we follow the last method, it will take us to all the 12 soil texture classes, so which is little bit laborious. But we will do this short one today that will divide the texture into the 5 groups. So we'll follow these steps, take a small sample, put some water, try to make a ball, then bounce the ball, try to rub it. If it falls, then group 2, group 3, then group 4, group 5. We'll follow these steps and find out what the texture of the soil that you collected this morning. So there is another step to determine the ribbon length. So when you are pressing between the index and the thumb, then you try to make a ribbon. Then you can use a ruler to determine the length of the ribbon, and that's how it will determine the different text classes here. soil texture classes, okay? So use a ruler to determine the length of the ribbon you form. If it doesn't break apart, then if it's more than 2 millimeter or so, then go to the next step. So that's why we have a ruler in the bucket for your use in the classroom. There is another method to determine the soil texture. So we did have this for the demonstration here. So I know it's not clear enough, the soils are too dark, but at the bottom we have the sandy soils, and at the top we have about silt and very small amount of the clay. So what we do in this jar method is take about half a cup of soil, put about 1.5 cup of water, shake it. That's what we did yesterday, but we added a little sand this morning because we couldn't see any layers settle down. So after about a minute, 45 seconds to a minute, you will see the bottom layer as a sand, and then let it settle down. Then about a couple of hours you will see the silt. Then about 24 to 48 you will see the top layer as a clay. So that's another method to determine the texture, but there are some calculations involved. Can work on the calculations part of it to determine the percent of sand, silt and clay, and then we can talk about which part of the triangle it falls. Okay. So for instance, this is the jar as an example. The total, if we take from the bottom to the top layer of the soil, the total depth, that's measured as the total depth, which is about 2.3 inches is the total depth, right? So the lowest one is the sand. So we take the ruler, take the depth of the sand, height of the sand. Then the middle one is the silt, take the height of the silt above the sand. Then the top one is the clay, then take the height of the clay above the silt. So take all three heights, and then we'll use this, then write those heights in here, okay? 1.4 inches for the sand, then 0.7 inches for the silt, then 0.2 inches for the clay. So that's the three heights we got from the jar. Then use this methodology to determine the percent of sand, silt and clay. So how that is going to be, take the sand depth, which is 1.4 inches, divided by the total depth, which is about 2.3, right? 2.3 of total and 1.4, multiply by 100. So that will give us the sand percent, similarly for the silt and similarly for the clay. So with this, I did a calculations earlier. It comes about 71% of sand. Then we have about 30% of silt and about 8.7% of the clay. So if you want to go along, you can calculate too and see which part of the triangle it falls. Let's do that quick calculations and see where it falls in the triangle. The silt.
30.
And clay?
9.
Okay, good. So we have sand about 61%, right? So we go from bottom to up. Then the silt will go from these lines along. Then the clay will be the horizontal. And tell me which group, which class it falls. So it falls here in the sandy loam. So make sure the percent always adds to 100%, and that's where the triangle will take us to.